why do we feel bad? Why don't we just feel good all the time? Happy emotions feel good, and they play a clear role in social and romantic connections. On the other hand, the purpose for negative emotions is a whole lot less clear.
Freud thought that negative emotions were likely the result of childhood or birth trauma, but Freud also thought that penis envy was a real thing. Others consider negative emotions to be products of a situation, as a result of the human instinct to like or dislike things without much consideration as to how they might be helpful.
Recent evidence suggests that in reality, at least some of these negative affective states, like disgust, grief, anger, sadness, and depression, all have, or at least had, a purpose. There's a reason why we like and dislike things after all. If poison berries tasted good to us, then a whole lot more of us would die from eating them.
But not all connections are that simple. To understand how negative affect states help us survive, let's talk about how they interact with some evolutionary pressures. We may need to reframe our understanding of emotions. Humans tend to organize reality into simple categories, which may or may not actually represent the shapings of natural selection. Human survival revolves around the pursuit of specific resources and therefore the avoidance of their loss, and thus bad feelings are aroused by loss, potential loss, and failure to reach goals. There is therefore potential for overlap between affect states such as grief and depression.
But there are a lot of different needs that humans have. Food might be, in context, less important than companionship. Let's categorize these needs. There are somatic needs, like food and shelter, or health and wellness. There are reproductive needs, mating or parenting. And there are, of course, social needs, alliance, companionship, status, and power.
Our emotional regulation systems are designed to optimize the transmission of genes to maximize reproductive success, not individual satisfaction.
And it's important to note that behavioral recognition and emotional mechanisms evolved in an environment completely different from the one we currently live in. Let's look back in human history to see where emotions come from. A new conception of emotion, based on the idea that evolution shaped affect states, recognizes that negative emotions can be useful in particular situations, and positive emotions are sometimes maladaptive. Motivation for fruitless endeavors or pursuit of impossible goals. This idea may be disturbing to consider, but sometimes negative emotions help us achieve our goals. Let's look at grief first.
Grief is a very unpleasant experience. Although it may feel futile in the moment, grief, like many other negative affect states, has a specific adaptive function that helps individuals cope with the loss of existing social resources. Grief is a dual-faceted process centered around loss and restoration. Loss-oriented functions are internally focused, helping an individual make meaning of their loss and cope with the emotional fallout. Restoration-oriented functions are particularly important for social species as they help restore and strengthen social connections. Social contact helps mitigate the stress of interpersonal loss, and the affective state of grief facilitates this contact.
The loss of a close kin member or grooming partner in baboons often leads to a prolonged increase in stress levels in affected individuals. In turn, baboons increase their grooming behavior and diversity in grooming partners, which likely helps mediate that stress. Social support, particularly skin-to-skin contact, is critical to bond formation and reducing stress. Social contact releases oxytocin, which reduces inflammation and glucocorticoid levels, as well as promotes affiliative behaviors. The loss of a loved one can be extremely stressful, so it is likely that grief could motivate individuals to seek out social contact in order to mediate the stressful effects of loss.
So, how does grief foster social bonds? Well, grief affects much more than just the griever. It is theorized that grief functions as a social signal which reliably communicates non-aggression and the need for assistance to others. Signals, first and foremost, serve to influence the behavior of others. Remember, grief is mentally and physically taxing. Additionally, grief behavior leaves an individual vulnerable to aggression from others and limits one's ability to access necessary resources. Thus, in order for grief to persist as a near universal attribute, the expression of grief must confer benefits to an individual.
What do we know about this bird? We know how he died, flying into the glass doors.
Grief behaviors signal to observers that an individual is in a vulnerable situation, essentially functioning as a sign of capitulation and a plea for help. Social contact is part of our basic needs, and grief is a way that someone going through a loss can invite social contact in such a way that alleviates potential partners' fear of being taken advantage of.
They know it's a genuine signal because grief is really hard to fake.
Was that convincing?
Not really. Grief is difficult to imitate because it has distinct emotional expressions.
Displays of grief often involve crying, which is very difficult to imitate without a lot of practice. And crying leads to more physiological hallmarks of grief, the classic red and puffy eyes and runny nose. Not only is faking grief technically difficult, the fact that grief is such a taxing, costly process makes it less likely to see imitators in the first place. Accordingly, observers typically respond by reducing aggressive behaviors towards the affected individual and engaging in comforting behaviors like social support, and in the case of baboons, grooming.
Additionally, grief signals can serve as an indication of one's ability to form close social bonds, or rather their desirability as a social partner. Humans commonly make judgments about an individual from their grieving behaviors. Those who conform to socially appropriate norms of grieving, as opposed to those who mourn minimally or not at all, are perceived as more sympathetic and likable. Accordingly, individuals are more inclined to partner with high grievers on trust exercises, and they report higher levels of trust that the griever will act cooperatively. Grief behaviors can signal to others the value of oneself as a social partner and indicate need for assistance. Thus, grieving individuals receive the support they need to cope with the stress of loss through their grief signaling, and their compatriots get a caring ally in return. But people recognize that grief is necessary.
Grief isn't wrong. There is such a thing as good grief.
Just look at how people react to those that don't grieve or grieve wrong. It's still an adaptive response today. But what about a negative affect state that is generally considered harmful, not universal, and unnecessary, specifically depression? Why would natural selection ever result in us being able to become depressed?
Depression has its own hallmarks that make it clinically and neurologically distinguishable from grief. Moreover, depressive behavior doesn't garner the same positive social response as grief. Instead, people with depression are typically avoided and viewed negatively.
Have you tried being happier?
Unlike grief, depression doesn't seem to have a consistent external trigger. Depression can seemingly come out of nowhere. Everyone seems to have a different idea about what causes it, from seed oils to video games. These popular theories attribute depression to convenient external scapegoats, but the neurobiology of depression suggests that it once was an important, inherent reaction that helped us to survive, closely associated with the immune response.
When we get injured or invaded by some pathogen, our body responds by activating the sympathetic nervous system, which, in turn, causes a long cascade of reactions. This sympathetic process, mediated by the HPA axis, is what underpins our inflammatory response. Inflammatory cytokines promote the production of T cells that attack foreign cellular invaders, and the production of adhesion molecules that help immune cells migrate from circulation to an injured or infected area. And the immune system activates before an injury occurs by listening to the chemical signals that often precede injury, ones produced by a stress response.
The connection between the stress response and the immune system, or the inflammatory response, makes a lot of sense when you think about the stressors that we faced way back.
In pre-societal times, common stressors faced by humans included the presence of a predator, physical threats or attacks from other humans, or the existence of a disease spreading among compatriots. Therefore, stress reactions strongly correlated to a higher risk of injury or infection, making it adaptive to have an immune system that is activated in response to stress. Those who had the ability to mount an inflammatory response earlier were more likely to survive the ensuing challenge and reproduce. Those stressors are also why we have the fight or flight reaction. That too helped us survive acute threats like predators, interpersonal violence, or war. And while ravenous mountain lions or murderous cavemen are the most Hollywood-friendly threats faced by early humans, the research consensus is that infection was the most common cause of death in pre-industrial societies, and likely accounted for well over 50% of them. Accordingly, more research has begun to recognize how much the threat of disease and infection shaped our brains, bodies, and even emotions.
A lot of the things we think of as sickness are actually adaptive responses to getting sick, like fever, decreased appetite, and sleepiness. And these responses go beyond automatic physiological responses we have no conscious control over, such that the immune response also affects our behavior.
No way. I just want to watch Criminal Minds.
In many species, sickness causes changes in behavioral routines. Sick animals often eat or forage less, withdrawing socially or isolating themselves. In humans, even a perceived pathogenic threat is associated with wide-ranging changes in social judgment and behavior, increased preference for in-group versus out-group individuals, higher expressions of disgust, and prejudice against those with physical differences, the elderly, disabled, or obese. The inflammatory response has wide-ranging consequences on our perceptions and behavior, and research has begun to consider whether it might play a major role in depression. Researchers have found significant links between the inflammatory process and depression. Cytokines, C-reactive proteins, and glucocorticoids all are involved in inflammation, and also are thought to play a direct role in stress and depressive symptoms.
In the short term and the right context, this response can be helpful.
But in the long term, the stress reaction becomes potentially quite harmful. In the short term, glucocorticoids mediate inflammation. But when glucocorticoids are released over a long period of time, glucocorticoid receptors become less responsive, resulting in chronic inflammation. Cytokines affect the reward pathways in the brain, altering motivational states. This is helpful in the face of a stressor, which requires conservation of energy, but is costly, especially if it persists over long periods. Further, the inflammatory reaction increases activation of threat and anxiety-related areas of the brain, and of course, sensitivity to threats and high levels of anxiety, worry, and rumination are very common symptoms of depression. These connections are more than just hypothetical biomarkers that indicate chronic activation of the inflammation pathways. They're both predictive of depression and characteristic of those already diagnosed. Higher levels of inflammatory biomarkers significantly predict the development of depression, even among bereaved individuals already facing a large stressor. Depression is best understood as a product of our response to pathogenic threats.
But how would triggering depression help us survive disease? If it's selected for, then it has to be helpful for an individual's fitness. Well, actually, there are a few ways. There are behavioral benefits like promoting avoidance, risk assessment, and hypervigilance. Also, the activation of depression pathways has physical benefits as well, like decreased locomotion, which conserves energy for the fight against infection. Hyperthermia, or the increase in core body temperature, and reduced iron levels are also anti-pathogenic. The problem is, the smoke detector principle means that these systems are quite sensitive. No, not that kind of smoke detector. This is just another way of saying that when the costs of missing a real threat are higher than the costs of a false alarm, then the detection system will produce more false alarms than false negatives.
Society today is much different than it was 10,000 years ago. We face very different stressors today than we did before. Thanks to modern medicine, infection doesn't represent as great a danger as it used to. But our neurobiology still reflects the world that it was produced in, not our current environment. In the evolutionary scheme of things, medicine, urban society, and the structures that result have only been happening for a millisecond. Natural selection is a long, slow process. Our brains and our bodies represent thousands and thousands of years of development shaped by the incentives and the demands of a life that doesn't resemble ours in the slightest. This leaves us with depression pathways that operate on a hair trigger because our systems are still attuned to the specific threats that humans used to face.
Yeah. Depression is generally not adaptive today, at least not in most contexts. But when you consider the environment that shaped the depressive response, its existence makes a lot more sense. At one point, it helped us survive. Even negative affect states that are today classified as disorders are there for a reason.
Both positive and negative affect states have diverse and multimodal impacts on our fitness. There are many different needs we need to fulfill to survive and reproduce, and just as different positive affect states relate to different needs, so do negative affect states. Grief and depression are examples of this, two negative affect states that helped humans survive in very different ways.
Feeling bad is just as diverse and useful a phenomenon as feeling good. Anyone can tell you that bad feelings are just as powerful as good ones when it comes to affecting our behavior. It's easy to blame the world around us for why we don't feel good all the time, but in truth, bad feelings are there quite often to help us deal with threats, challenges, stressors that will always exist, just not necessarily in the same form that we are optimized to deal with.